Hello, my name is Emma Reed. I'm an 8th grade math teacher. Today our lesson is going to discuss describing large and small numbers using powers of 10. So on slide A, you have your introduction and launch. We are interpreting and explaining. So we're going to examine the diagram below and then describe what we see in the space provided. So in your own words, describe what you see in this diagram. And whenever I'm looking at a new diagram in math or a graph, I like to think about what I notice and what I wonder. So in the blue box, you can talk about what you notice, what you see, and some ideas that you're wondering about. And when you've had enough time to write, we'll move on to slide B. So slide B takes us with the same diagram to think about some specific math questions now. So using this diagram from slide A, we're going to answer the following questions. If each small square represents one tree, what does the whole diagram represent? If each small square represents 10 books, what does the whole diagram represent? If each small square represents 1,000,000 stars, what does the whole diagram represent? If each small square represents 1/10 of a second, what does the whole diagram represent? If each small square represents 10 to the third power people, what does the whole diagram represent? So now you're going to hold in your mind some things that you noticed about this diagram, and you're going to respond to each of these questions. And you'll notice that the questions are telling you a unit for your quantity. So in the first question, the quantity is 1, and our unit is a tree. In the second question, our quantity is 10, and our unit is books. So you want to keep in mind both the quantity that you come up with and the unit that you need to express in your answer. So now take some time to look back at that diagram and connect it to each of the questions on slide B. And when you're ready, we'll move along together to slide C. So slide C is the beginning of our Explore section. And on this slide, your goal is to draw lines to match each expression to one or more diagrams that could represent it. So these diagrams have a lot of similarities to the diagram we started with in our launch. So you can use some of the things that you noticed about those diagrams here. Our first expression says 2 times 10 to the negative first power plus 4 times 10 to the negative second power. So you'll ask yourself which one or more diagrams could represent that expression. B says 2 times 10 to the negative first power plus 4 times 10 to the negative third power. C is 2 times 10 to the third power plus 4 times 10 to the first power. And D says 2 times 10 to the third power plus 4 times 10 to the second power. So now pause, take some time to decide which diagrams or diagram could represent each of the expressions A through D. And when you're ready, we'll take a look at some students' thinking, and you can reflect as we move forward into the rest of the lesson. So here we have two students' answers for the matches for D, our expression D, which was 2 times 10 to the third power plus 4 times 10 to the second power. So on the left, you can see James matched this expression to diagram C, and he labeled a little bit to show his thinking. And then on the right, you can see Destiny matched this expression to diagram B. And she labeled a little bit differently to show her thinking. So take a moment and decide, do you agree with James? Do you agree with Destiny? And why? You can also look for the way that James and Destiny labeled their thinking and consider, are there any strategies you want to use or improve upon when you work on showing your thinking in the future slides? So now move along with me to slide D, still in our Explore section. And on slide D, we're going to start to write expressions. So here we need to write an expression to describe this diagram if the small square represents 10 to the first power. So when we write an expression, we are expressing in math language the relationships that we see. So my expression might not look exactly like another student in my class's expression, but that doesn't mean that I'm right and they're wrong. There can be multiple correct expressions to show the same information. So when you think you have an expression that represents this diagram, if we think of the small square as 10 to the first power, we're going to move on to slide E and think similarly about new diagrams. So on slide E, we're going to look at two more expressions and write an expression to describe the diagram for each of the following values of the small square. So the diagram is the same, but in A, you need to think about the small square representing 10 to the third power. And in B, you're thinking of the small square as representing 10 to the negative fourth power. So take some time to come up with your expressions. If you happen to finish before the rest of your class finishes, or if you're working on your own, challenge yourself to come up with more than one expression that could represent these diagrams. And when you're ready, we'll move on to the end of our Explore section on slide F. And on slide F, you're going to get to be really creative. So you're going to choose your own value for the small square and write an expression to describe the diagram. So challenge yourself to pick a power of 10 or a different value for the small square that is just enough to challenge you. And then describe on the right the connection between the diagram and your expression. Take some time to really come up with some clear thinking here, and at least one expression, but you can always make more than one. And then we'll go along to our summarize section and be done for the day. So in our summarize section, we're going to be answering how are powers of 10 used to represent very large or very small numbers. And on the right, you can add any notes that come up as you're discussing with your class or anything you want to definitely remember from today. Thank you for joining me, and have a good rest of your day.